Hello everyone, welcome to a very beautiful platform of Minervaa, myself Suman Singh. So today we are going to discuss the first chapter of Icse class 10th, which is periodic properties of the element and its periodicity. Okay, so as we know that in all total nowadays, if you will see, there are 118 elements, right? And in this 118 element, you will see that there is natural, okay, natural as well as man-made. Okay, man-made means what? Which we have made it, which we have created, right? So in this 118 element, you will see that there is natural and man-made also, but man-made are very few. I think between 90 to 96 are man-made, right? And still the research are going on to discover more and more elements, right? So as we know that there are 118 elements, and it becomes very difficult to study this element one by one, right? If you will study this element one by one, it will become very difficult to study, right? So the scientist has tried to improve, or we can say that to develop a method through which we can study this element very easily, or we can say that we can study this element very easily or very effectively, right? So for this purpose, there was a need of periodic table, right? So I hope we have got this right. Now next week we can say that why there is a need to classify, why there is a need to classify, why there is a need to classify. So what will be the answer? We can say that the classification is important because through this classification, the first thing what we can do this is we can study the elements systematically, right? The first thing what we can say that with this classification, the periodic classification of the element, we can systematically study the element, right? Now if you will see that, if you will see the periodic table, you will see that the similar number of elements, or we can say that similar properties of element are in the same vertical column or group. Like this you will see that, right? Periodic table diagram is like this, suppose like this. So you will see that same number of elements, same properties of the elements are repeated are there in a same vertical column or a group, right? So these are the two things what we can do. After that, through this periodic table, we can predict so many properties of the element, and it become very easy for us to classify, for us to study these elements, right? So in this periodic table, so whatever the periodic table we are seeing now, it was not like that before, right? Because previously, if you will see in 17th centuries and 18th centuries, at that time very few elements were known, right? So now as the day has passed, more and more element has discovered, and now we have come to 118, right? So we will see what was the discovery and who has contributed what in developing this modern periodic table, right? So first development, we will see from the Dovenus stride, okay? So the first development was made by Dovenus, right? In a form of stride. We will see this, what is Dovenus stride, right? Dovenus stride, right? So what is Dovenus stride? So when we talk about the Dovenus stride, Dovenus, what he did, what was his contribution towards this? He told that if we are arranging the element in order of increasing atomic number, means what? If you are arranging the element in order of increasing atomic number, atomic mass, okay, atomic mass, you will see that the elements, means what we can say, if you are increasing the element in order of their increasing atomic mass, suppose A is greater than B is greater than C, okay, is greater than C. So you will see that the element, the atomic mass of, if you are combining this, if you are finding out the arithmetic mean of these two elements, we can easily find out the mass of this element B. Okay, so what does he said, that if you are arranging the element in order of their increasing atomic masses, you can easily find the atomic mass of the middle element by finding out the arithmetic mean of these two elements. So how we can write, if you are asked to find out the atomic mass of element B, so we can find out like this, right? I am writing here. So we can find out like this: atomic mass of element B will be A plus C divided by 2. Like this we can easily find out, right? So this was basically about the Dovenus, right? So let us take one example. Okay, so the best example is, you can take the best example as lithium, okay, and sodium and potassium. Okay, these are the three elements. You can take a best example. So we know that if you will take the atomic mass of lithium, it is approximately 7, and for potassium we can take 39. Okay, so now if we are asked to find out the atomic mass of lithium with the Dovenus triad, we can easily find out the atomic mass of this sodium. How we can find out? Just what we have to do, we have to just add this 7 plus 39 divided by 2, we will get what? Here 23, approximately 23. So which is the atomic mass of sodium. So I hope you have understood this, right? So this was about the Dovenus triad. But since this Dovenus triad has a drawback also, because nowadays we are whatever the periodic table we are seeing now, it is different, right? So it is not like the Dovenus. So what was the limitations of the Dovenus triad? The first limitations was Dovenus triad, we cannot, according to the Dovenus triad, we cannot place all the elements according to the Dovenus triad, okay? Because whatever the system there Dovenus is given, that system was not applicable for all the elements, right? So what we have did, this was a major drawback, okay? So since this Dovenus triad, from this Dovenus triad, it is very difficult to place all the elements according to the Dovenus triad. So what did the scientists did? Actually we can say that this Dovenus triad has failed, right? Now after that, one more scientist was there whose name was Newland. Okay, Newland. He has also, what he did, he also studied the physical and the chemical properties of the element. Okay, and after we can say that studying the chemical and the physical properties of the element, what he did, he has adopted a system, or he has taught a system, he has given a system, and with this system what he taught, that if we are arranging the element in order of their increasing atomic mass, right? If we are increasing the element in order of their increasing atomic mass, okay, Newland, let me write here, Newland law of octaves it is called, right? So what did he say? He said that if we are arranging the element in order of their increasing atomic mass, right, like this, suppose 1 2 3 4 5 6 7, right? If you are increasing if you are arranging the element in order of their increasing atomic mass like this, so you will find that the atomic mass of the 8th element, okay, will be similar to the first one, okay? Or we can say that the properties, or the chemical properties or physical property, you can say that of the, actually especially chemical property, the chemical property of the 8th element will be similar to the first one, okay? So what we can say, for 1 it will be 8, for 2 it will be 9, for 3 it will be 10, for 4 it will be 11, 12, 13 and 14, like this he told, right? If what he told that if you are increasing the atom, if you are placing the element in order of their increasing atomic mass, then you will find that the atomic mass of the 8th element will be similar to the first one, okay, will be similar to the first one. So we will see that what is that element. So first we are arranging like this, from hydrogen, here lithium, beryllium, boron, carbon, okay, nitrogen, oxygen, okay, if you are arranging like this. Now after oxygen, here what will come? Here will come fluorine, okay, after that sodium. At that time noble gases was not there. You always notice that these gases, when Newland has given this helium, neon, argon, krypton, xenon, and radon was not there, right, at that time. So as you can see, hydrogen, after that not helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, okay, fluorine, sodium, magnesium, aluminium, okay, silicon, phosphorus, and sulfur, right. So in this way he has arranged this. After that, again if you will see, after that 14, it will be here 15, 16, 17 and 18 like this, right, 19 and 20, like this he has arranged. So what did he tell? He told that if you are arranging the element in order of their increasing atomic mass, as you can see that the atomic mass of the first or we can say that the properties of the first element will be similar to the 8, 1. For that, if you what we can say, for 2 it will be similar to 9, for 3 it will be similar to 10, for 4 it will be similar to 11, okay, for 5 it will be similar to 12, like this. So I am erasing this one, right. So as you can see, now we will see the properties. So as we all know that when you will see the properties of hydrogen, so the properties of hydrogen is similar to that of fluorine, right, because the position of hydrogen, if you are talking about the position of hydrogen, it is still debatable, okay, because it resembles the properties of both alkali metals and halogens also, right. So that is why we can say that the position of this hydrogen is still debatable. So you will see that when you will see the hydrogen and fluorine, they will have a same chemical property. As you can see, if hydrogen its atomic number, if you will see the electronic configuration of hydrogen, it is 1, right, and for fluorine, if you will see, for fluorine what we can write, 2 and 7, right. So it need 1 electron to complete its octet, and here if you will talk about the hydrogen, it need 1 electron to complete its doublet, right. So in this way we can say that this hydrogen and this fluorine both are having a same chemical property as that of lithium and sodium. Both of them has a similar chemical property. Beryllium and magnesium, similar chemical properties. Boron and aluminium, similar chemical property. Carbon, silicon, after that nitrogen, phosphorus, and oxygen and sulfur. You will see that all of them have a similar chemical property. So in this way Newland has arranged his you can say that he has arranged this element in order of their increasing atomic mass, and he found that the atomic mass of the every 8th element is similar to the first one, and properties of the every 8th element is similar to the first one. So this was about the Newland law of octave. But now here you can see that the Newland law of octave has also failed. Why it has failed? Because it was applicable up to only calcium, okay, it was applicable up to calcium only. Beyond calcium, when we are placing in this way, which is called the Newland law of octave, the properties were not matching, okay. So that was a drawback, you can say that was the failure of the Newland law of octave, okay. So when you will see that up to beyond calcium, if you try to place these elements in the form of a Newland law of octave, at that time you will see that it will not arrange in this form, okay. So this was the main drawback about the Newland law of octave. So I hope you are clear about this, right? Now we will see next, which is Mendeleev periodic table. So which is a very important contribution. What we can say, Mendeleev periodic table is a great, what we can say, it is a great achievement for in the terms of modern periodic table, okay. So what is Mendeleev periodic table? So Mendeleev, what he did, he has done the same thing what Newland has did, but at that time when the Mendeleev was making a concept of this periodic table, or between, we can say that when the Mendeleev was arranging these elements, at that time there was 63 elements were known at that time, okay. So what Mendeleev has did, he has studied one by one all the elements, okay. He has studied one by one all the elements, and what he found that if we are arranging the elements in order of their increasing atomic mass, okay, what Mendeleev has found that if you are placing the element in order of their increasing atomic mass, at that time atomic mass at that time the element with the similar property will be arranged in a same vertical column, okay, or same vertical column or group, okay. So what did he said? If we are arranging the element in order of their increasing atomic mass, right, the element with the similar chemical property will come in a same place, right. What did he say? As you can see, for example, in Mendeleev periodic table, you will see that there was 8 group, 1, 2, 3, 4, 5, 6, 7, and 8 group was 0 group, okay, 0 group, right. In this way he has arranged this element, okay. So in Mendeleev periodic table you will see that there was all total 8 group, okay, in which the 8th one was 0 group, okay. Now, and he was having a 7th period, as you can see, 1, 2, 3, 4, 5, 6 and 7 period, okay. Now what he did, he has subdivided this group into 2, right, in the form of A and B, in the form of A and B, okay, in the form of A and B, in the form of A and B. Like this he has arranged the element in the form of A and B, okay, A, B and A, B, here also A and B, okay. And 0 group he left like this as it is, right. So this was basically the design or model of the Mendeleev periodic table. You can see that there are 1 to 7 in a Roman number, and the 8th one is he called as a 0 group, now which we are calling as a inert gases or noble gases, right, group 18 elements, right. So this was the arrangement in which he has given the 7 group and 1 is 0 group. After that 7 period, as you can see, okay, and he has arranged the element. So when he has arranged the element, he found that the element with the similar chemical properties are placing on the same, right. As you can see, for alkali metal, if you will take the example of alkali metal, it will be lithium, sodium, potassium, rubidium, cesium and francium, right. So this will come in a same row. As you can see, all of them has a similar chemical property. Why they have a similar chemical property? Because in the outermost cell of these elements have one electron, right, and since the chemical property is depends upon what? It depends upon the number of electrons in the outermost cell, right. So as you can see, this was the basic system of arrangement by the Mendeleev, right. Now what has happened here, that Mendeleev's main contribution, what we can say that he has left some of the gap in his periodic table, okay. As you can see that what he did, he has left some gaps, and what did he do? What he did was he has predicted the properties. He has predicted the properties of the undiscovered element, okay. What he did, he has predicted the property as by taking the reference, or we can say the relevance from the other element which he has placed in the group. What he did, he has predicted the properties of that element, right. So what was that element? We will see one example. So he has predicted an element called Ica aluminum, okay, and Ica silicon, right. So when he has predicted this element Ica aluminum and Ica silicon, so after some year, so scientist has found that whatever the property this Mendeleev has given, and whatever the property Mendeleev has given, the properties of that similar property, one element they have discovered, okay. Suppose he has given some property, Mendeleev, okay. Mendeleev has given, suppose this is a gap here and this is a gap, okay. For these two gap, what Mendeleev had did, he has predicted the property of this in this element. What he said that in this element there some element will come here, okay, and after some time there will be a discovery and some element will come here and whose property will be like this. He has told that property, okay. So after some years, scientists have discovered that the same property which Mendeleev has predicted, the same property with that property, two elements has been discovered. The one which he has given the name Ica aluminum was gallium, okay, Ga, and the one which is called Ica silicon, here it was found as germanium, okay. So I hope you have understood this. So this was the main contribution of the Mendeleev periodic table, right. Now next, what we can say, with this Mandalay periodic table, first time we have understood that we can study the elements by making a table like this. Okay, from the first time, what we can say that with this Mandalay periodic table, we came to know that for the first time that we can arrange this element in this way in a form of a table and we can study them. Okay, so for the first time the word periodicity, or we can say that periodicity or periodic table word has came into existence with this Mandalay periodic table, right? So this was all about the Mandalay periodic table. I hope you have understood this, right? Now next we will see the drawback. What was the drawback? Because nowadays whatever the periodic table we are using, they are what? It is a long form of periodic table or modern periodic table, right? So we will see what was the drawback. So now the first drawback, if you will see for the Mandalay periodic table, was the position of hydrogen. So as you can see, the position of hydrogen, when we talk about the position of hydrogen, just now I have told you that hydrogen resembles the similar property with alkali, metals, okay, and halogens, okay, these two elements. As you can see, hydrogen resembles both the properties of alkali as well as halogen, but Mendeleev, what he did, he has placed the element in group 1. Okay, in group 1 he has placed hydrogen, right? So this was the first drawback. Now second drawback, what he did was, you can see what he did, the second mistake was in Mandalay periodic table, not a mistake, you can say the drawback was the argon and potassium, right? So since we know that potassium, the atomic mass of potassium is less than that of the argon, right? As you can see, if I am writing here, argon and potassium. So atomic mass, when we talk about the atomic mass of argon, it is potassium, it is 39.1, right? And argon is 40, approximately 40 something, 40.2. So what he did was, he has placed argon before, after that he placed potassium, right? I hope you are understanding this. In the same way, cobalt and nickel, if we talk about the cobalt and nickel, what he did, he has placed cobalt before nickel, right? So I hope you are understanding this. So this was a major drawback of Mandalay periodic table. What he did, actually what was the Mandalay periodic table, I will tell you that he has generally focused on the properties, not on the atomic mass, right? He has told in his definitions that the periodic properties of the elements are the periodic function of their atomic masses, but most of the time he was focusing on the properties, similarities in properties, not on the similarities in atomic mass, right? So as you can see, that is why he has done a mistake. He placed argon before potassium, cobalt before nickel. So this was the major drawback of Mandalay periodic table, right? Now next we will see isotopes. Okay, I hope all of you know what is isotopes. Isotopes, I hope you know that, right? So isotopes are what? Elements having same atomic number but different mass number, right? So you can see that nowadays what we are seeing in modern periodic table, it is purely based on atomic number, right? So since it is purely based on atomic number, so we cannot say that the concept of this isotopes will not come here, because isotopes is you will see that in isotopes the atomic numbers are same. So and since the modern periodic table is based on atomic number, so isotopes concept will not come there. But if you will see the Mandalay periodic table was based on atomic mass, right? It was based on atomic mass. So the concept of isotopes in Mandalay periodic table, you will not find any concept regarding the isotopes. He has not told anything about the isotopes, right? So that is also a drawback of Mandalay periodic table. So I hope you have understood this, right? Now we will see the modern periodic table or long form of periodic table which we are now using. Modern periodic table, right? So now when we talk about the modern periodic table, so modern periodic table based on what? Atomic number, right? It is based on atomic number, And what we can say, mostly for the first time he has seen that what he did was, he actually, one thing I would like to tell you, that just try to focus this. If suppose A is reacting with B, okay, if A is reacting with B, so what actually is happening here? There is an exchange of electrons, right? There is an exchange of electrons. If A is reacting with B and it is forming AB, so between them, what has happened here? There is an exchange of electron, either sharing, or either A is giving to B, or they are sharing. There are 2 or 3 types, right? 3 types of bond we have learned. You have learned, right? Covalent bond, electrovalent bond, and coordinate bond, right? So with this 3 process, they are saying, suppose. So what is happening here? You will see, there is an exchange of electron, right? Exchange of electron. So what we can say from here, what we can conclude, that the chemical properties of the element is basically depending on this electron, right? That is because you can see, we have seen that sodium, if you talk about sodium, lithium, you will see one electron in its outermost shell, right? So that is why their properties are same. So what we can say, the chemical property generally depend on the number of electrons. So that is why the modern periodic table is based on this concept only. He told that the chemical and the physical properties of the element are the periodic function of their atomic number, not the atomic mass, right? As you can see, in a neutral atom, electron and protons are similar, right? Right. So what we can say, the periodic function of the element, or we can say that the chemical properties of the element are the periodic function of their atomic number. And in atomic number means what? Nowadays we are using number of proton, right? So if it is a neutral atom, then we can say that atomic number is equal to number of electron also. So right. So this was the concept of atomic number, that the chemical and the physical properties of the element are the periodic function of their atomic number, not the atomic mass, which was given by Mandalay. Okay, so this discovery has changed the entire concept of periodic table. Okay, and a new concept was generated, which is called a modern periodic table, right? So now we will understand about the modern periodic table. So as you can see, in modern periodic table there are 18 group. As you can see, this side is called group. Okay, and this side is called what? Period. This side is called period and this side is called group, right? So as you can see, there are 18 groups in modern periodic table, as you can see, right? And there are 7 period, okay, 1, 2, 3, 4, 5, 6 and 7. Okay, as I have already discussed, the first period is called what? In the first period there are 2 elements, okay, and this period is called very short period. Okay, after that the second and third period consist of 8 elements, which is called short period. Okay, now next fourth and fifth period is called 18 elements, and it is called what? Long period. And after that, 6th and 7th period, which has 32 elements, which is called very long period, right? So this was about the modern periodic table, right? Now, with this modern periodic table, as we have already discussed, that it is based on the concept of what? Atomic number, right? So because since it is made on the concept of atomic number, so most of the possibilities, most of the drawback which was in modern Mendeleev periodic table, now it has been solved, right? As you can see, position of hydrogen is still debatable. Okay, in most of the periodic table chart, you will see that in some they have placed in with this alkali metals, or some of them has placed in the middle, right? You will see like this, that but you can see that most of the time the position of hydrogen is always debatable, right? But what this modern periodic table has solved, it has solved the concept of, I am writing here, it has solved the concept of isotopes. Okay, because it is based on the atomic number, not atomic mass, right? Now next, what it has solved, it has also solved that most of the element which was placed before, just like in the case of potassium and sodium, potassium and argon, right? As you can see, and cobalt and nickel, this thing it has solved, right? This atomic number in this modern periodic table has solved this concept also, right? So I hope you have understood this, what is modern periodic table, right? So nowadays we used to use this modern periodic table. Now we will see the trends or variation, which is very important. Now one more thing I will tell you, that for your ICSE class 10, okay, for this year only, you have to mostly focus on these three elements, the group 3 up to group 3 only, okay. Most of the question which will be asked, it will be asked on the basis of group 3 only, right, and below that it will not ask. You can see the syllabus, right. So now the most important things according to the ICSE syllabus is the variations. We have to learn about the variations, okay, just like the variations like atomic size, atomic number, okay, atomic size, atomic metallic properties, non-metallic property, ionization enthalpy, okay, and electron affinity, electronegativity, right. This thing we have to learn, right. So we will first, when we will start the trend, so what are the trend we have to see? First trend we have to see was atomic size, okay, or it is called radius. So what is atomic size or atomic radius? We will discuss about this first. So atomic size or atomic radius can be understand very easily. Suppose we imagine that there are two atoms which is in the form of a sphere. Suppose, okay, there are two atoms which is in the form of sphere like this, and this is just touching each other. Suppose this is just touching each other, okay. So but we have assumed that this is an atom which is in the form of a sphere, and this is an atom which is in the form of a sphere, okay. And this is what? This is the center of this circle, and this is the center of this atom, okay. Now what will be the atomic radius or atomic size of this element? So it will be from, if we are going from here to here, and if we are coming from here to here, right. So this area is called what? Atomic size or atomic radius, okay. We can write like this, okay. This is what? This area is what? This area is atomic size or atomic radius. So I hope you have understood this, right. So we will see the trend also. First of all we will learn the term, after that we will see the term, okay. So I hope you have understood this, right. Now next we will see what is metallic and non-metallic character, okay. First of all, metallic character. So metallic character, when you talk about the metallic character, you have also learned, right, if in the outermost shell, if there is 1, 2 or 3 electrons in the outermost shell of an element, it comes under the category of what? Metal, okay. And if they have 5, 6 or 7 or 8 electrons in their outermost shell, they are called what? They comes in the category of non-metals, right. Now one more thing, we know that metal has a tendency to donate electrons. Let me give you one example. Metal has a tendency to give electrons, right, in the form of this, in the form of like sodium. You can take one example, it is changing into Na+. So right, metal has a tendency to give one electron and convert into cation. This concept I hope you have learned in class 9, right. And here also this is what? cation, cation, right. Now next, when we talk about the non-metallic character or non-metal, okay, non-metallic character. So what we can say, non-metals are those which have 5, 6, 7 or 8 electrons in their outermost shell, and they have a tendency to gain electrons, right. As you can see, the example of chlorine, the best example is chlorine. If we are giving one electron, it is converting into Cl minus, right. If fluorine, if we are giving one electron, it is converting into F minus, right. If you are taking iodine, so if you are taking iodine here, so iodine has a tendency to take one electron and it is converting into I negative, right. So as you can see, these are all what? These are all non-metals, right. These are non-metals, right. So I hope you have understood this metallic character and non-metallic character. We will see how in periodic table what is the trend in metallic character, what is the trend in non-metallic character, right. So this concept, I hope you have understood this. Now we will see next concept, which is ionization enthalpy, which is a very important topic. In class 11 also you will learn about this in ionization enthalpy. So I will give you one example. Today we will learn this. Ionization energy or ionization enthalpy, okay. Now we will see this, what is ionization enthalpy and what is ionization energy. So I will give you a very simple concept about this. Suppose this is a proton and neutron, okay, and this is an orbit or shell, okay. This is not like this actually, but we are taking like this example. Suppose this is a proton and neutron, and here the electron is there, right? Here is the electron. Suppose one electron is present here, right? So ionization enthalpy or ionization energy is what? Amount of energy required to remove an electron, okay? Amount of energy required to remove an electron from the outermost cell of this atom, okay? From the outermost cell, this is the outermost cell for this atom, right? This is the outermost cell for this atom, this is the outermost cell, right? So whatever the amount of energy required to remove an electron from an atom is called what? Is called ionization enthalpy, right? I hope you have understood this. How much amount of energy will be required to remove an electron from an isolated gaseous atom, okay? Amount of energy required to remove an electron from an isolated gaseous atom is called what? Ionization enthalpy or ionization energy. So I hope you have understood this, right? So as you can see, I will give you one more example. If the nuclear, now next, I hope you have understood this, right? Now next we will see, next one is nuclear charge, okay? Now next is nuclear charge. Now next is nuclear charge. So what is this nuclear charge? So nuclear charge, suppose next, again we will give the example proton and neutron. Suppose there is the first cell, second cell, third cell. So in third cell one electron is there, right? So amount of energy, or we can say that the amount of energy through which this nucleus is attracting this electron is called what? Nuclear charge. Okay, I hope you are getting this. As you can see, the amount of energy through which this electron is going, this neutron or this nucleus is, we can say that this nucleus is attracting this electron is called what? Nuclear charge. I hope you are getting this, right? Now next, if I will say, as you can see, if I am going, this is suppose one more example for nuclear charge. Suppose we are taking here two electrons, okay? Suppose here is proton and neutron. This is the first cell, second cell, okay? And again one here it is proton and neutron, this is the nucleus, here this is the nucleus. So 1, 2, 3 cells, right? Here first suppose this is the K, L and M, right? And here also 1, 2, 3 and 4 suppose. Here K, L, M, N, right? And in this also there is one electron, here also one electron, okay? So now if you were talking about this electron, the amount of if it is both of them have, suppose both of them are same atom, okay? Both of them are atoms are same. Just try to understand this, okay? Suppose they are both are same atom, okay? So what we can say, the amount of nuclear charge will experience by this electron will be lesser than this, will be greater than this, right? Because why? As we are moving from, as you can see, it has 1, 2 and 3 cells, right? And here you can see 1, 2, 3, 4 cells. So as we are moving away from the nucleus, right? As we are moving away from the nuclear charge is what? Decreasing, right? As you can see here also, if here you can see the distance is not much, right? But here you can see the distance is increasing, right? So as the distance is increasing, what will happen? The nuclear charge will decrease. Okay, I hope you are understanding this. So that is why this electron which is present here will experience a more nuclear charge as compared to this electron. So I hope you have understood this, the concept of nuclear charge. So we will use this concept in understanding the trend, okay? Now next is electron affinity. So what is electron affinity? Now this is what we can say opposite of ionization enthalpy. How we can define this? Very easily, as you can see. What we can say that amount of energy, okay, amount of energy required, or which we can say amount of energy released, okay, when we are adding an electron to an isolated gaseous atom. Means what? As you can see, suppose this is a proton and neutron, this is a nucleus here, this is the first cell, second cell, okay. Here is one electron, here is 1 2 3 4, sorry, not like this, as you can see here. Let me draw it again. Suppose this is a proton and neutron, and here 1 2 second cell. Suppose in the first cell there is 2 electron, and in the second cell suppose there is 7 electron, 1 2 3 4 5 6 and 7 electron, right? Now one more electron is needed here. So the amount of energy required for this electron to go and sit here is called what? Electron affinity, right? Or we can say that amount of energy released when one electron has been added to the outermost cell of an isolated gaseous atom is called what? Electron affinity. I hope it is just reverse, right? In ionization enthalpy, what we have seen, amount of energy required to remove one electron from here, from an isolated gaseous atom, that was ionization enthalpy. The opposite of this is electron affinity, which is the amount of energy released when one electron, or we can say that when the electron is added to the outermost cell of a gaseous atom, isolated gaseous atom. So this is what? Electron affinity. Right? So I hope you have understood this, right? Now next concept is the electronegativity. So electronegativity concept, this is a very important concept in the entire chemistry, okay? You will use this concept in your organic also, or especially in organic you will use this electronegativity concept very much, okay? So electronegativity. So what is electronegativity? So what we can say, when we are asked to define this electronegativity, we can define like this, that the electronegativity is the tendency of an element, or we can say that tendency of an element present in a molecule to attract a shared pair of electrons towards itself. I hope you are understanding this, right? Electronegativity is what? It is the tendency. Suppose this is an A and it is making a bond with B, okay? So this is a molecule, suppose this is a molecule, and the tendency of this A, okay, suppose we are taking the example of say A. The tendency of this A to remove a shared pair of electrons, suppose the 2 electrons, they are sharing one electron each, right? So the tendency of this A to attract this shared pair of electron more toward itself is called what? Electronegativity. Suppose I will give you one example. Suppose we have here carbon and double bond oxygen, okay? We have carbon and double bond oxygen here. So as we know that the electronegativity of this oxygen is more, right? The electronegativity of this oxygen is more than carbon, right? So what it will do, whatever the electrons which has been shared here, this oxygen will attract the shared pair of electron more toward itself, right? It will attract a shared pair of electron more towards itself, so that what will happen at that time, this oxygen will carry a partial negative charge and this carbon will carry a partial positive charge. That is the concept of electronegativity, okay? Once again, let me tell you what is electronegativity. It is the tendency of the molecule which is present, it is the tendency of the element which is present in the molecule to attract a shared pair of electron towards itself. And with this, what will happen? They will generate a partial negative charge. The one who has attracted, or we can say the one who has taken the shared pair of electron will generate a slightly positive charge, and the one who has from where the electron has gone will carry a slightly positive charge. So I hope you have understood the concept of this electronegativity. Now again, one more example. Suppose we are taking here carbon and hydrogen, okay? Suppose we are taking here carbon and hydrogen. At that time, carbon has a more electronegativity of carbon is more, right? So what will happen? This carbon will attract a shared pair of electron from hydrogen, and it will generate a partial negative charge and it will generate a partial positive charge, right? So I hope you are understanding this, right? So this was the concept of electronegativity, which we have to use in understanding the trend in the periodic table, right? Now, next thing, before jumping into the trend, we will start again with atomic size, okay? Atomic size. So we will start with the atomic size. So as you can see, when we talk about the atomic size, just try to understand this. If we are moving from down the group, okay, or if we are moving towards the period from left to right across the period, okay, if you are moving like this, across the period from left to right, okay, and if you are moving from top to bottom, okay, if you are moving from top to bottom like this in a periodic table, we are talking about periodic table, okay, if you are moving from left to right, if you are moving from top to bottom, what are the changes you will see in the size, atomic size? You will see that as we are moving from top to bottom, the atomic number is increasing, right? If you're talking about the lithium, okay, sodium, potassium, rubidium, cesium and francium, you will see that as we are going down and down, the atomic number is increasing, right? As you can see, 3, 11, 19, like this atomic number is increasing. Since the atomic number is increasing, what will happen? The atomic size will increase. Means what? Atomic number is increasing, means the atomic size will also increase. How? Because as the atomic number is increasing, number of cells will increase, right? Number of cells, suppose it was proton and neutron, this one first cell, so here it will become proton, neutron, first cell, second cell, right? 2 cells, right? And here also, if you will see, it will become proton and neutron here, 1, 2, 3, 4. Means what we can say that as we are going down the group, number of cells are increasing, right? Since the number of cells are increasing, then what we can say, suppose this is a nucleus here, just try to understand this concept, because if you will understand this, then the trend you will understand very easily and it will be very easy for you to understand the trend, okay? So as you can see, if we are going down the group, atomic number is increasing. What are the thing which is increasing? Atomic number is increasing, right? Now, after that, since atomic number is increasing, then what will happen? Number of shells will increase, okay? Since the number of cells are increasing, then you can see that the proton and neutron, if you will see the nucleus and the outermost cell, the distance between them will increase, right? So if the distance between them is increasing, the distance between the nucleus and the outermost electron, which is called valence electron, okay, if the distance between the nucleus and the valence electron is increasing, then the atomic number will also increase, right? Then the atomic size will also increase, right? Because as you can see, in the first time there will be 1 cell, after that 2 cell, 3 cell, 4 cell, means what? The distance between the nucleus will increase day by day, right? Suppose I will give you just one more diagram here. Suppose this is the nucleus, for this is the nucleus, for this is the nucleus, right? This is the nucleus. Suppose for lithium the distance was this, right? So for sodium it will become this. Suppose this is the outermost cell of valence shell. Suppose this is the valence shell, okay? And for this is a valence shell. So as you can see, as we are going down, you will see that the valence shell will increase, and it means the number of cells are increasing. So the valence shell, you will see the valence shell, the distance between the valence shell and the nucleus will also increase, and the atomic, since the valence shell is increasing, atomic size will also increase, right? So I hope you have understood this. So what we can say, as we are moving down the group, the atomic number, or we can say that the atomic number is increasing, and since the atomic number is increasing, the number of cells are increasing, and since the number of cells are increasing, the atomic radius, or we can say that the atomic size is also increasing, right? So I hope you have understood this. Now we will talk about if you are moving from left to right, okay? So now you just imagine one thing, if we are moving from left to right, atomic number is increasing, right? You will see that when you will see lithium, after that if in the modern periodic table you will see like this: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, right? In this way, if you are going down the group, after lithium, beryllium, boron, carbon, nitrogen, oxygen, right? If you are moving like this, you can see that number of atoms, you can see that atomic number is increasing, right? But as you can see, since as we are moving from left to right across the period, what will happen? The number of, as you can see, atomic number is increasing. Atomic number is increasing, right? Atomic number is increasing, but you will see that number of shells remain the same, right? As you can see, since we are moving from left to right across the period, atomic number is increasing, but number of cells is not increasing, right? Because we are talking about second period, or if we are talking about third period or fourth period, and across the period, the number of cells will be same. We know that, right? So as you can see that since the atomic number is increasing, but the number of cells is remaining the same, right? So since the number of cells remains same, what we can say, the atomic radius or atomic size will decrease. How? As you can see here, if suppose we are talking about lithium, right, you can see 2 and 1, right? If you are talking about sodium, 2, 8 and 1, okay. We will take the example of lithium, after that beryllium, boron, carbon, nitrogen, up to this, okay, only this thing. So if you will take the example of this lithium, it is what, 2 and 1, right? And beryllium it is 4, right? To 2, 2, right? And boron is 2, 3, right? For carbon is 2, 4, right? And for nitrogen is 2, 5. This thing like this you have understood, like this you have learned about the electronic configuration. What you are noticing that here number of cell is how much? 1, 2. Here also number of cell 1, 2. Here also 1, 2, 1, 2 and 1, 2. Means number of cells is not increasing, right? But what is increasing here? Atomic number, right? Atomic number is increasing, and since atomic number is increasing means number of protons and electrons, or we can say the number of protons and neutrons. Number of protons and neutrons is increasing, right? As you can see, if atomic number is increasing means number of proton and neutron is increasing. And since the number of proton and neutron is increasing, then what we can say? Nuclear charge. Nuclear charge is also increasing. So since the nuclear charge is increasing, what will happen? If this is a nuclear charge, this is a nucleus here, and since the nuclear charge is increasing, then what will happen? The electron which is present in the outermost cell, it will be attracted more powerful, or we can say it will be attracted more towards the nucleus, right? And what will happen if the nucleus is attracting, suppose we are taking the example of if the nucleus is attracting the electrons more toward itself, then what will happen? If suppose this is an electron and this is the nucleus, or we can say that this is the nucleus and this is an outermost electron, and since the nuclear charge, this one is increasing, what will happen? The electron will come more closer towards the nucleus, right? Since the nuclear charge is increasing, what will happen? This electron will come more close towards the nuclear charge, right? And towards the nucleus. So at that time, what will happen? The shell will contract, right? The outermost cell will contract, and since the outermost cell is contracting, what will happen? The atomic size will decrease, okay? Atomic size will decrease, right? I hope you are understanding this. So once again, let me recall this one. So as you can see, when we are moving from top to bottom in a group, right? In a group, when we are moving from up to down, since when we are moving from like this, when we are moving from like this, moving like this across the group, or we can say that top to bottom, down the group, or we can say that down the group. At that time, what was happening? The first thing, atomic number was increasing, right? Second thing, if the atomic number is increasing, then number of cells were increasing, right? Number of cells were increasing, but you can see since the number of cells is increasing, but one more thing, one question arises that when we are moving from top to bottom, at that time nuclear charge was also increasing, right? So, but here what is happening here, that the nuclear charge, whatever the nuclear charge which is increasing when we are moving from top to bottom, at that time the nuclear charge, as you can see, that at that time what we can say, the nuclear charge was overcome by overcome by this number of cells. That is why or what we can say, simply what we can say, if you are moving from down the group, at that time whatever the nuclear charge which is increasing, that will not affect the number of cells. Means what? Number of cells will overcome that nuclear charge. That is why what will happen, the number of atomic size is increasing. But in this case, when we are moving from left to right across the period, at that time what you will see that the number of the cells was remaining same, 2 or 3, 4 like this, right? So number of cells was increasing, and moreover the nuclear charge was also increasing. So at that time what we can say, the nuclear charge was increasing and number of cells was not increasing. So at that time nuclear charge will dominate this cell, and that is why what will happen, this nucleus, when we talk about this nucleus will attract the electrons, outermost electron present in the valence cell towards itself. And what will happen at that time, the size of the atom, or we can say that the size of the element, will decrease as we are moving down the group. So at last what we can write, on moving down the group, atomic size increases. Why it is increasing? Because number of cells are increasing, atomic number is increasing. So atomic number and number of cells will overcome the nuclear charge, and the atomic size will increase, right? Now on moving from left to right across the period, what we can say, the atomic size decreases. So as you can see, why it is decreasing? Because number of cells remain same, nuclear charge is increasing, and since the nuclear charge is increasing, it will attract the electron more towards itself, and what will happen? The atomic size will decrease. So I hope you have understood this concept, because if you have understood this concept, then it will be very easy for you to find out if you are moving from left to right in the period, or if you are moving from left to right down the group. So what is happening at that time, you can easily identify this, right? So I hope you have understood this, right? So now now we will see the next topic, which is metallic character. Okay, so I hope you have understood the concept of this atomic size. So let me remind you again what I have told you, that if this is an atom, and if it is these two are atoms, so if this is the center of this atom, so what we can say, that from here to here it will be the atomic radius of this atom, and from here to here it will be the atomic radius of this atom. Okay, and this distance is called what? Internuclear distance. And if you will divide by 2, you will get the atomic radius of this entire molecule. Okay, what I have told you, if you are going down the group, what is increasing? Atomic number is increasing, right? And number of cells are increasing, so atomic radius or atomic size will increase. Okay, and if we are going along the period from left to right, what we have seen, that the atomic number was increasing, but the number of cells was remained same. So that is why the atomic size or atomic radius was decreasing, right? So this was the concept of atomic size or atomic radius. Now in next we will see metallic and non-metallic properties, okay, or trend in metallic and non-metallic character. Okay, so when we talk about the metallic and non-metallic character, you will see that, let me write here, metallic and non-metallic character. So in metallic character, we know that metal has a tendency to donate electrons, right? If you take the example of this lithium, or if you take the example of sodium, what they have a tendency to donate electron, right? They have a tendency to donate electron, and it will convert into Li plus. Okay, and if you're talking about the sodium, it will donate electron and it will convert into Na plus, right? So if you can easily identify metallic and non-metallic metal like this. If they have 1, 2 or 3 electrons in their outermost cell, or you can say the valence cell, they comes under the category of metals, right? Because they can easily donate 1, 2 or 3 electron, right? And after that, if they have 5, 6 or 7 electrons in their outermost cell, then they will be a non-metal, right? So we will see the trend. So we know that metal has a tendency to donate electron, right? It can easily donate electron to convert into electropositive ions, right? So as you can see here, if we are going down the group, what we have seen that if we are going down the group like this, at that time what you will see, what are the things it will increase? Atomic number will increase, right? And since atomic number is increasing, and side by side nuclear charge is also increasing, right? Nuclear charge is also increasing down the group. But if the atomic number is increasing and nuclear charge is increasing, number of cells will also increase, right? Number of cells will also increase, and since the number of cells, what it will do, it will overcome this nuclear charge, right? So what will happen if you are going down the group from 1 2 3 like this, if you are going down the group, so what will happen, from the nucleus, the distance between the nucleus and the valence electron will become more, right? If you will go down the group, the distance between the nucleus and the valence electron will increase, or we can say it will increase, right? Like this, as you can see in the diagram, right? So when we are going down the group, the distance between the nucleus and the valence electron is what? It is increasing, right? And since the distance between the nucleus and the valence electron is increasing, what will happen? The nucleus, the force of this nucleus, or we can say that the attraction pull of this nucleus will decrease, right? Because it is going far away from the nucleus, then attraction pull will decrease. Like if you are taking this A, if you are taking this B, and this was if you are taking this as a C, then at that time, in which case the attraction will be more? In this case, right? In the case of A, attraction will be nucleus will attract more in case of A, and after that B, and after that C, right? In this way it will move, because as we are moving far away from the nucleus, as you can see, the attraction force between this nucleus and this valence electron will decrease, right? So it will be very easy for this atom to donate its electron, right? It will become very easy for this atom to donate its electron, right? So what we can say, since it will become very easy for this atoms to donate its electrons, so what we can say, as we are moving down the group, the metallic character will increase, okay? What we can say, down the group, metallic nature will increase, right? I hope you have understood this, right? Now next we will see about the non-metallic character, right? Now after that, if we have seen down the group, now we will see across the period, okay? So as you can see, what I have told you, when we are going from left to right in a period, what we will see that there is an increase in atomic number, right? And when we were moving across the period from left to right across the period like this, and when we were moving at that time, what are the things which was increasing? The atomic number was increasing, right? Atomic number will increase, right? And after that, again the next thing what it will increase, since atomic number is increasing, nuclear charge will also increase, okay? But the number of cells, when we talk about the number of cells will remain same, okay? So what we can say that if we are moving across the period, so what we have seen, atomic number was increasing, right? And since atomic number was increasing, nuclear charge is also increasing, and since nuclear charge is increasing, number of cells will remain same, right? And number of cells is remaining same. So what you can say, you see here, if we are moving like this, suppose this is our proton and neutron, and this is one example of this, and this one is second cell. And if it is a third cell like this, if it is going like this, so if it is 2 here, this is also same, and this is also same. But if suppose we take the example, both the 3 are same. So in the first case, suppose it was 2 electrons was there and 1 electron was here, suppose. In the second case, 2 electron was here and 2 electron was here, as you can see. In the third case, 1 2 3 and 1 2 like this, as you can see. So you see here, the number of cells is remain same, right? Here also K, L, N, K and L, here also K and L, here also K and L, right? K and L. So you can see that number of cells is remain same, but you can see here the number of electron was how much? In the first case it was 3, in the second case it has become 4, in the third case it has become 5, right? So as you can see, the number of electrons is increasing. Why electrons is increasing? Because the number of proton is also increasing here, right? So in this case the number of proton will be 4, in this case number of proton will be 5, and in this case it will be 3. So since the number of cells is remaining same and the number of proton is increasing, means the nuclear charge will increase, right? And since the nuclear charge will increase, at that time what will happen, this nucleus will attract this electron more towards itself, right? This, and so what will happen, this cell will decrease. Now if you will see the diagram, it will be like this. If this is if you will see the diagram, it will be like this. Suppose this is a proton and neutron, this is the first cell and this is the second cell. So for next one it will become like this. It will be little bit smaller than this, okay? And the third one, it will be more smaller than this, okay? It will be more smaller than this, because when this, since the nucleus, in the nucleus proton and the percentage of, we can say that the number of proton is increasing. So if the number of proton and neutron is increasing, what will happen, the nuclear charge is increasing. So nuclear charge is increasing, then it will attract electron more towards itself. Then at that time what will happen, the size will decrease, right? This one we have also discussed in the atomic size. So since you see here, the size was decreasing here, and since the size is decreasing, then the electron which is present here, this electron will be attracted more towards this nucleus, right? So it will be very difficult to remove this electron from here, right? So if it is very difficult to remove this electron from here, so what we can say, when we are moving across the period like this, at that time the metallic nature is decreasing, okay? The metallic nature is decreasing. As you can see the example of lithium, okay? After that lithium is what? It is a metal. Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. You will see that these two are what? These two are metal, right? And if you will see this, leave out this one from here to here, this is what? They are all what? Non-metal, right? They are all non-metal. This comes under the metalloids, so no need to talk about this. So as you can see, when we are moving from here to here, it is changing. First of all it was metal, and after that it has changed into non-metal. Means what? When we are moving down the group like this, at that time the metallic character is decreasing, right? Because the nucleus, when you see the nuclear charge is increasing, and since the nuclear charge is increasing, the electron which is present in the outermost cell, or we can say that the valence cell, it is attracted more towards the nucleus, right? So what will happen, it will be very difficult to remove this electron from here. So that is why the metallic character will decrease, right? So I hope you have understood this, right? Now next we will see the non-metallic character, okay? So non-metal is what? Non-metal has a tendency to accept electron, right? Non-metal has a tendency to accept electron. You can take the example of chlorine. So chlorine, it will take one electron and it will convert into Cl minus, right? So as you can see, they have a tendency to accept an electron, right? So as you can see, when we are moving down the group, okay, if you are talking about non-metallic character, okay, non-metallic character, so when we are moving down the group, at that time what are the things which is increasing? Atomic number, okay, nuclear charge and number of cells, right? Number of cells, these three things was increasing when we are moving down the group. So at that time what will happen, you see, a non-metallic character is what? If anyone is accepting an electron, then it will be a good non-metal, right? If it is very easily, if someone is accepting an electron, then it will be called as a what? They are good non-metals, right? But as you move down the group, as you can see, why they will accept an electron. First of all, the reason is why they will accept an electron, because the nucleus will pull that electron towards itself. Who will do the work of this accepting an electron? The nucleus, which is present in this, right? Chlorine. The atom in the chlorine atom, if suppose we are talking about the atom, this is an atom, right? Suppose this is an atom. So who will accept an electron from here? This nucleus, right? Because of this nucleus, and the electron will come here, right, in this cell. So as you can see, when we are moving down the group, at that time the distance between the nucleus and the valence electrons was increasing, right? The distance between the nucleus and the valence electron was increasing, right? So since the distance between the nucleus and the valence electron was increasing, so it will become very difficult for this nucleus to attract the electrons, right? To attract this electrons, or we can say that the valence electron, or the electron which will come in the valence electron, it will become very difficult for this nucleus to attract that electron, right? So what we can say, down the group, the non-metallic character decreases, okay? When we are moving down the group, what we can say, down the group, non-metallic non-metallic nature, okay, decreases. Okay, so I hope you have understood this, right? Now we will talk about across the period. So when we are going across the period from left to right, as you can see, when we are going from left to right across the period, okay, so at that time what will happen? You see, what are the things which was increasing? Atomic number increasing, nuclear charge is also increasing, let me write in a short form. Atomic number was increasing, okay, nuclear charge was increasing, but number of cells what remains same, okay. Since the number of cells remain same, so what will happen? Then what will happen? The distance between the nucleus and the valence electron will decrease, right? If suppose this was the distance in the first case, if we're talking about the second period or third period, in the first case, suppose the distance between the nucleus and the valence electron was this, right? So when we are moving down the group across the period like this, at that time the distance will decrease. Let me write here so that you can understand. Suppose this was the first case where nucleus was there and this was the valence electron, right? In the second case, when we are going from here to here, if this is a nucleus and the distance between the valence electron will decrease like this, okay. In the third case, if it is a nucleus and this will be the valence electron, right? So as you can see, when we are moving from here to here, from left to right across the period, the distance between the nucleus and the valence cell was decreasing, right? So since the distance between the nucleus and the valence cell is decreasing, so what will happen? The nucleus will attract more, it will exert more force, or we can say that more energy to pull that electron towards itself, right? So that is why when we are moving across the period, and when what we have seen non-metallic character is what? Tendency to take electron, right? To accept electron. So as you can see, when we are moving from across the period, the tendency to accept electron is increasing, right? Because the nucleus is attracting this valence electron more towards itself, and moreover the distance between the nucleus and valence electron is less, right? So what we can say, across the period, when we are moving from left to right across the period, the non-metallic character, non-metallic character or nature will increase. I hope you have understood this, right? Very simple concept. Now, next we will talk about ionization enthalpy or ionization energy or ionization potential, okay? So when we talk about the ionization energy, ionization potential or ionization enthalpy, so ionization energy, you will so we know that ionization energy is what? The amount of energy required to remove an electron from the valence electron, to remove an electron of an suppose this is an atom, and we have discussed about this, right? And this is an atom, so amount of energy it will be required to remove an electron from this valence cell, right? So this is called ionization energy, right? So when we talk about the ionization energy trend, what we can see when we are moving down the group like this, okay, when we are moving down the group, at that time what was the things which was increasing? Atomic number, okay, nuclear charge, okay, and number of cells. These three things was increasing, right? So since these three things was increasing, always remember that the two factors, right? The two factors. First factor is number of cells, or you can say that yes, number of cells, and number two, the nuclear charge. These two factors will affect all the time, right? So as you can see, when we are moving down the group, the distance between the nucleus and the valence electron, the distance between the nucleus and the valence electron was increasing, right? Distance between the nucleus and the valence electron is increasing. As you can see here, distance between the nucleus and the valence electron is increasing, right? So if the distance between the nucleus and the valence electron is increasing, then what will happen? It will require less energy to remove an electron from here, right? Because the attraction force between this nucleus and the valence electron is less, right? Since the attraction force between this nucleus and the valence electron is decreasing, then it will require very less amount of energy to remove an electron from the valence cell, right? So what we can say, across the period when we are moving from down the group, at that time ionization energy or ionization enthalpy decreases. decreases, right? Ionization energy decreases on moving down the group. So I hope you have understood this, right? Now next, when we talk about the across the period, so across the period, what are the things which was increasing? Same thing. When we are talking about when we are going from left to right across the period, left to right across the period. So what was happening here? Atomic number was increasing, same as it is, and after that atomic number was increasing, nuclear charge was increasing, but the number of cells was not increasing, right? Number of shell remain same, right? So since the number of cells remain same, then distance between the nucleus and the valence electron, the distance between the nucleus and the valence electron will decrease, right? Since the number of cells is remaining same, then what will happen? The distance between the nucleus and the valence electron, will decrease, right? So since the distance between the nucleus and the valence electron is decreasing, at that time what will happen? The attraction force between this valence cell and the nucleus will increase, right? So it will become very difficult to remove this electron from here, right? So at that time, if you want to remove this electron from valence cell, if you want to remove an electron from the valence cell, it required lots of energy, right? So what we can say, across the period, ionization enthalpy, or you can say ionization energy, increases, right? So I hope you have understood this, because to remove an electron, since the attraction force between this nucleus and this valence electron is high, right? So to remove this, it required lots of energy, right? So we can say that across the period, the ionization enthalpy or ionization energy increases. So I hope you have understood about this, right? So now next we will go to electron affinity, okay? So electron affinity was what? Amount of energy released, okay? Amount of energy, we have discussed about this, right? Amount of energy released when we want to add an electron to an isolated gaseous atom, right? So we will talk about electron affinity. So when we talk about the trend, we always remember that this electron affinity we represent in a negative value, okay? We see the negative value of we talk about the negative value of electron affinity, right? So across the period, when you will go like this across the period, down the group, or if you are going across the periods, and then what will happen? Same thing. You just imagine like this. Same thing. What will happen when we are going from left to right in a period, then the tendency to accept, or we can say that the negative value, okay, negative value of electron affinity, we can say that the negative value of electron affinity will increase, okay, when we are moving from left to right across the period, when we are talking about the period, okay. So across the period, when you will see that the negative value of ionization enthalpy will increase, okay, if you are moving from here to here. Now across the down the group, the negative value of electron affinity will decrease, okay. So this was about the electron affinity and electronegativity trend down the group and across the period, and the reason is same. Electron affinity, why it is decreasing, negative value of electron affinity is why it is decreasing across the period, across the group, because down the group, because nuclear charge was decreasing, okay, and the number of cells was increasing. Nuclear charge was number of cells, and nuclear charge, what it will do, it will overcome, right? Number of cells will overcome the nuclear charge. So at that time what will happen? The electron affinity, the negative value of electron affinity will decrease, and when we are moving from across the period, the negative value of electron affinity will increase, right? So I hope you have understood this also. Now next topic, which was electronegativity. So we have discussed about this, what is electronegativity? The tendency of a molecule in an atom to attract a shared pair of electron towards itself, right? So this was electronegativity. electronegativity, right? So when we will see the trend of electronegativity down the group or across the period. So just imagine like this. What is electronegativity? Means what? Tendency to attract the shared pair of electron towards itself, right? So if you are going down the group, then what are the things which was increasing? Atomic number was increasing, right? Nuclear charge was increasing, right? Nuclear charge was increasing. After that, number of cells was increasing, right? And moreover, number of cells was increasing means distance between the nucleus, okay, and valence electron, distance between the nucleus and the valence electron was also increasing, right? Okay, distance between the nucleus and the valence electron is also increasing, okay, Then what will happen? It will become very difficult for the elements, which is, or we can say that it will become very difficult for the element to attract the shared pair of electron towards itself, right? So when we are moving down the group, the distance between the nucleus and the valence electron is increasing. Then what will happen? The nucleus and between the valence electron and the nucleus, there will be a very less forces of attraction, or right? So it will become very difficult for the elements which is present in down the group. It will be very difficult for them to attract a shared pair of electron towards itself, right? They have a tendency to give the electron. Just in the case of, you can take the case of this alkali metal like lithium, sodium, potassium, okay, rubidium, cesium and francium. You will see that francium is what? It is not electronegative, they are electropositive, means they have a tendency to donate electron, means the distance between the nucleus and the valence electron will become so far that so big, or we can say that so long that it will be very difficult for the nucleus of francium to attract a shared pair of electron towards itself, right? So that is why they are called as what? Electropositive elements. They are called electropositive element. One more example I will give you about the group 17, okay? Group 17 halogen family, you will see that fluorine, if you talk about the fluorine, chlorine, bromine, iodine, okay? So you will see that they have electronegativity, their electronegativity is very, very high. Why? Because they have a tendency to attract a shared pair of electron towards itself. So what we can say, when we are moving down the group, electronegativity was what? Increasing or decreasing? As you can see, when we are moving down the group, electronegativity was decreasing, right? And if you are moving across the period from lithium, if you are approaching to like this fluorine, if you are sodium if you are approaching to chlorine, or from potassium to bromine, or rubidium to iodine, at that time you can see that they have a very high electronegativity, right? They have very high electronegativity. So what we can say, across the period electronegativity increases, okay, increases, and down the group electronegativity decreases. So I hope this concept you have understood. So about electronegativity and electron affinity you will learn in class 11 also, because in class 11 they have given in detail the periodic classification of element. There you will learn this, okay? So now we will talk about that atomic number and atomic mass, okay? Atomic number. So Mosley was a scientist. He has done, and he has studied the properties of the element, okay, properties, chemical properties and physical properties of the element, and he found out that, and when after studying that property of the elements, he just plotted that properties on a graph, okay, and he found out that the atomic number, the concept of atomic number is more periodic. Means what? If we are arranging the element in order of their increasing atomic number, we are getting a better trend than atomic mass. You will learn about this in a periodic table in class 10. So you will see that the modern periodic table is based on this atomic number concept only. So what is atomic number? Atomic number is nothing but a number of proton, okay, number of proton in a neutral atom, okay. In a neutral atom, atomic number is equal to number of proton, okay, or you can say that in a neutral atom, atomic number is equal to number of proton or number of electrons, okay. So number of electron concept will be valid only if there is a neutral atom, okay. So this was about the atomic number, and next topic is atomic mass, okay. So atomic mass, when you talk about the atomic mass is what? It is the atomic mass is equal to number of proton plus number of neutron, okay. number of neutron. Okay, number of neutron. So as you can see, if you are talking about the atomic number or atomic mass, if here, so atomic number is denoted by Z, okay, and atomic mass by A. So what we can write, X is equal to A Z. Here you will write Z, okay, here A, okay. So for this, if you take the example just like lithium, if we can write here 3 7. For sodium you can write here atomic number is 11, mass number is 23. After that, for potassium you can write 1939 here, okay. Like this, you have for oxygen you can write here 8 16, right? So this is the concept, or this is the way of writing the atomic mass and atomic number of an element, right? So I hope you have understood about this atomic number and atomic mass, and you have understood this periodic classification of element, class 10, right? So if you like this video, you can hit the like button and don't forget to subscribe. Okay, thank you.